Welcome back guys. Today I'm gonna start working on a new sensor that is TMP101NA, that's a temperature sensor. Regarding the recent videos we have showed, we have been working on different digital temperature sensors. So let's add a new one to that series. And to know more about this sensor, let's have a look over the website that is controleverything.com and here search on for this sensor that is TMP101NA. Now we see that it's a digital temperature sensor with alert function and it's a I2C temperature sensor 9 to 12 with user selectable resolution, and as you can see the accuracy is there. So some of its features you note it down. Now you can purchase this sensor from here also. For this video tutorial, I'm going to interface the sensor TMP101 digital temperature sensor with an Arduino Nano, and I require an Arduino Code. So I will go to the resource tab and here Arduino Code sample is here. Now you can download the Arduino Code sample as a zip file from here. Also, you can have the opportunity to download the code from GitHub repository that is Control Everything Community. Now let me have look over the hardware we require and let's make some connections so that we can set up a proper environment for the working of this sensor along with its code. First here is our sensor that is TMP101NA, and this here is an Arduino Nano which you are able to see on my screen. Now to make a connection among the sensor and the Arduino Nano, we require an I2C shield. And this is very useful in making connections with other I2C devices and rather make that connection a lot easier. So gently place over the Arduino Nano over the I2C shield, and let me tell you that it's available on the website controleverything.com also. Now we want to make a connection among the sensor and the I2C shield, and the binding factor is this a connecting cable. Now make a connection among the sensor and the cable and make sure that while making this connection, the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly we have to follow this rule for I2C shield. Now the last part is to power up the Arduino Nano, and here comes a mini USB cable into the picture. Now gently insert it over the power jack of the Arduino Nano and light it up. Hence we are done with the connections part for the hardware required. Now let's have a look over the code so that we can interface. Now we want to interface the Arduino Nano with an Arduino code or regarding the temperature sensor TMP101, and the best way to find the code is to log into the website github.com, and here we have to search for the official repository of controleverything.com, that's Control Everything Community. Now click over it and here our required sensor is. Now this is the code we would like to explore, but before that let's have a look over the instructions we need to follow and pursue this code, which says that we have download and install Arduino software IDE on our local machine, and the steps are being provided on this very link. Let's have a look over this link so that we can have a better viewpoint regarding the installation process. And it says that we can download the Arduino software and it runs on the Windows, Mac operating system and Linux. Now you can have a better viewpoint regarding this link. Get it done. Now get back to the code. As you see, it's a .ini extension file, and in the very first line of code we have included wire.h library and defined the address of the sensor, that is 0x49. Now in the void setup function we have initialized I2C communication as master, initialized serial communication with the baud rate equal to 9600. Then comes the writing section, where we have selected a configuration register having address 0x01, and the command we have sent to the sensor, that is set continuous conversion comparison mode 12-bit resolution, and that comprises of the command 0x60. As we are done with this part, now we want to have the response of the sensor back, and that's called the reading section, and here we have selected the temperature data register, that is 0x00, and we have requested and read 2 bytes of temperature data from this very register. Now at the end we have to convert the data which we have been pulling out, and it's according to the details being provided in the data sheet. Now at the very end of our code we want to display the output data onto the serial monitor, which is in the form of temperature and Fahrenheit, C and F scales. Now this is how a code looks like. It's a very generalized and simple code to follow. Now what we require is to show the working of this code regarding the Arduino Nano. Let's have a look over that also. Now this comes the very interesting part of this video tutorial, which is the practicality of this code. So the first step to follow this is to copy this entire Arduino code, then open up the Arduino. Now here we have to paste the entire code we have just copied like this and name it. Now it's TMP101NA for the reference, and here compile and verify the code. Now it's done compiling. Now upload the code. The code will be uploaded and it sometimes take a time to upload. Now it's done uploading. Now we have to check for the output data on the serial monitor. So let's open up, and we have our temperature data in Celsius and Fahrenheit scales. As you know, it's almost constant, but when I exhale, there's a change in temperature in Celsius and Fahrenheit. Now when I again do that, there's a change in temperature regarding the two scales, Celsius and Fahrenheit. So this is how the code works with Arduino Nano and the sensor. Now what do we require is to have a look over the benefits, features and the applications of the sensor TMP101NA. Let's have a look over there also. The TMP101NA device is a digital temperature sensor ideal for negative temperature coefficient and positive temperature coefficient thermistor replacement. The device offers a typical accuracy of ±1 degree Celsius without requiring calibration or external component signal conditioning. The TMP101 device features SMBus Two-Wire and I2C interface compatibility. The device allows up to 8 devices on one bus. The TMP101 device offers an SMBus alert function with up to 3 devices per bus. Now, this device is ideal for a lot of applications like power supply temperature monitoring, computer peripheral thermal protection, cell phones, battery management, thermostat controls, environmental monitoring and HVAC, and a lot more. This sensor is available and can be purchased from the website controleverything.com, and you can get the code from resource tab. After that, you can download it from there also. Also, you can get the code from GitHub repository, that is Control Everything Community. In the end, I would just like to make it clear that at any point, if you are not able to understand any part regarding any section of this video, you can have your further queries on controleverything.com, and you can post your comments on the community page. For blogs, articles which are relevant to this video, you can have a look over instructables.com and search us for them. Also, to subscribe more video tutorials which are just like this, you can go to our YouTube channel. Now, in the end, I hope you enjoyed this video and have a good one of yourself. Thanks a lot for watching.